Hope everybody, after looking through those practice problems from 2.1, helped clear up some stuff about sets and stuff like that. So we're going to jump back up into sets later in this section, but for right now, what we want to do is talk about a couple different numbering systems and do a little bit of examples to go along with these guys, and then we'll jump back into the set stuff some more. So the three type of numbers that we want to talk about are what are called cardinal numbers, ordinal numbers, and nominal numbers. So as you can see on the definition, a cardinal number tells us how many. So it's also like the counting numbers. So if you think about the set theory, when we were talking about how many elements were in a set, it was called the cardinality. Well, this is one of the reasons why, because it's a cardinal number, because you count up to it. So cardinal numbers always show quantity. Another thing you could think about is cardinal numbers are things that you could actually do arithmetic on if you wanted to or needed to. And so some examples of cardinal numbers would be, a bag of M&Ms contains 35 M&Ms because you could lay them out on the table and you could actually count them. There are 18 students in our Math 110 class. So again, we could walk around and kind of count our 18 students. And I scored a 95% on the math exam. So ordinal numbers gives you the order of things in a set. So like first place, second place, third place, things like that. So they don't show quantity. And so again, you wouldn't do arithmetic or anything like that because it wouldn't make sense to add like first place plus second place equals third place. Things like that just would be odd. So they always show a rank or position. So in this case, some examples of ordinal numbers would be, I finished my first K and came in 10th place. Avalon was the salutatorian at her school, which means she had the second highest GPA. I was the fifth in line to get movie tickets for the latest Marvel movie. So again, there's some kind of an order, there's a ranking that goes along with these. And then finally, nominal numbers is a name that identifies something. So again, it could be something like your telephone number, your FCC ID, social security number, a jersey number, anything that identifies it. So even though it's a number, again, you wouldn't do arithmetic on it because you wouldn't add two jersey numbers and get a different jersey number. Again, that would just be weird. You wouldn't add two social security numbers and get a different social security number. But they also don't have any kind of rank theoretically either. Like it's just, like even though mathematically we could put them in order, like that's not the way you really think about them. I mean, they're just a thing to identify this person is different from that person and stuff like that. So some examples of nominal numbers would be like the zip code for Frederick Community College is 21702. There are 18 students in our Math 110 class. So in this case, the 110 would actually be, a label for our class. And Zdeno Chara for the Boston Bruins has jersey number 33. So let's look at a couple examples of these so we can actually try to determine, which number is which. So in this case, example 1, so we've been given a set that has a red a red square, a blue square, a green square, and a yellow square. So the number of elements in set A is 4. So again, from last time we saw that n of A equals 4 means the cardinality of A equals 4. Is this a cardinal number, ordinal, or nominal? So again, cardinality tells us right away that this is actually going to be a cardinal number in this case. So again, is your social security number a cardinal number, ordinal number, or a nominal number? So since it identifies you, it would be a nominal number in this case. All right, so now we've got a bunch of numbers in this one. So 10 cars were in a race. Car number 33 was in second place after 5 minutes. So in this case, the 10 would be a cardinal number because it's how many actual cars were actually in the race. Number 33 is the identifying number, so it would be nominal. Second place, so it gives us a rank, so that's going to be ordinal. And then 5 minutes, again, would actually be a cardinal number in this case. All right, is that okay? Perfect. All right, so again, got lots of numbers going on here. So on the 21st of July, the hiking club will be meeting. Call blah, 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 blah for details. Thanks to all 26 members who were able to join us for the hike at Sugarloaf Mountain. So again, 21st, So that's going to give us a ranking because it's an order. So think of dates as orders and stuff like that. So years, calendars, stuff like that, they'd all be orders. So that would be an ordinal number. Our phone number is a way to identify us. So that's going to be a nominal number. And the 26 members are going to be the cardinal number in this case, because that's how many people that were actually in the members of the club. All right. So finally, we've got student ID with 157601 has won third place. He has won 4 tickets to a Washington Capitals hockey game. So in this case, our identification number IDs us, so that's going to be our nominal number. Third prize, again, tells us that there's an order to it. So this is going to be our ordinal number. And then how many tickets we've won, since we can count them, is going to be a cardinal number. All right. So hopefully everybody kind of gets those and stuff like that. So I will have like a little, just the definitions for the exit ticket, no practice ones, but there are some practice ones in the homework and stuff like that that you guys can work on. So if everybody's good with that, what we want to talk about next are what are called the natural and the whole numbers. And so these may look familiar, but one of the main goals that we want to work on in this class is we want to actually work through all these different number systems. Same way kind of elementary school kids are going to work through them. So the very, very basic or very beginning number systems that you work with are kind of the ones you can imagine, like if you took your fingers and counted on your fingers, you know, things like that. So that's why we want to talk about what are called the natural numbers and the counting numbers. And eventually we'll keep adding more and more numbers to our list. And again, we're going to learn about arithmetic with these different numbers, things we can do with them. And again, a lot of the reason we're doing the set theory stuff is because we're going to introduce set theory as a way to actually add whole numbers and stuff like that. So natural numbers are are also called counting numbers sometimes. And so they're denoted by this little fancy n. And as you notice, it just starts with n, or 1, and goes 1, 2, 3, 4, 5, ... the whole way up. And so the whole numbers are almost exactly like the natural numbers, except they throw in 0. So just kind of keep that distinction. It's very subtle, but they are slightly different. So counting numbers, no 0. Whole numbers include the 0 in our list. So keep that in mind. We're going to use that more in the next section. But for now, let's kind of get into some more set theory stuff here real quick. So if you look, this is similar to kind of the practice problem that we did in the last section. So again, what we're going to do is try to fill out this diagram, try to figure out where everybody needs to go, and then answer some stuff with it below. So all right, so let's take a look here. So we've got students in Miss Davis's class all belong to a club. The clubs are listed as follows. So A is going to be the art club. So in this case, we've got art. B is the book club. And then C is the computer club. And so again, we've got all these members in the class. And so what we want to do is kind of figure out where they all go. So again, we don't want to just like take set A and just throw it into A. We have to kind of be mindful of where everybody else lives. So that way, if they're also in B, they get into the right club. So let's start with Cindy, figure out where Cindy goes. So it looks like Cindy is only in the art club. So let's put Cindy over here. And again, I'm going to scratch these off as I use them so that way I don't kind of forget anybody as we go along. So Anna, it appears she's only in the art club also. So let's throw her over here as far away from the other circles as possible. So Tad looks like he is only in the art club as well. So let's throw Tad here. So Jane appears to only be in the art club. So let's put Jane here. Let's see, now Clara, it appears that Clara is in both the art club and the computer club. So we want to put her where both A and C intersect, but not the B part because she's not in B. So that means Clara is going to go over here. And that takes care of Clara from our list. So Jan appears to be in the art club and the book club. So again, we want to put Jan where A and B overlap. So again, let's put Jan here. And then Luz is in the art club and the book club, but it doesn't appear they're in the computer club. So Luz is going to go here. And then finally, Ken appears to be in all three clubs. So Ken's here, here, and here. So let's put Ken in the middle where all three clubs intersect. So let's get rid of these guys. So that takes care of all the art club. So now let's start into the book club. So we've got Pablo. And so it appears Pablo is in the book club and the computer club. So we want to put him where B and C intersect. So that erases both of those. So it looks like Jerry is in both the book club and the computer club too. So let's put Jerry in here. So Pete appears to only be in the book club. So let's put Pete up here. And Nancy also appears to be just in the book club. And so all the people that are left, so Joe, Robin, and Don, the only place they could be is just in the computer club. So let's write them down underneath. So we've got Joe, Robin, and Don. So in this case, there was no extra list of universal sets. So remember the one that we worked on last time had a universal set, and there were some things that were actually living on the outside. So in our case, all the people were in clubs, so we don't have to worry about people on the outside in this case. So when it says list all the students in the universal set, so in this case, we want to list everybody that's in all these different circles and stuff like that. So we'd have like Cindy, Anna, Jane, Tad, Jan, Luz, Pete, Nancy, Ken, Pablo, Jerry, Clara, Joe, Robin, and Don. And so we'd write them as one big list in this case. So we got Cindy, Anna, Jane, Tad, Jan, Luz, Pete, Nancy, Ken, Pablo, Jerry, Clara, Joe, Robin, and Don. All right, so that takes care of everybody that's in all the different circles. So now, using this information, what we want to do, I guess it fill out the diagram. So I kind of did these backwards, unfortunately. So, oh well. So fill out the diagram. We did that already. I guess I should follow my own directions. So now what it wants us to do is answer some questions about these different people. So in this case, it's saying who attends all three clubs. So in other words, in like set theory notation, what it would be asking is who is in A, intersect B, intersect C. So you don't have to write this out, but it doesn't hurt to kind of recognize like the word descriptions with the actual kind of set theory descriptions. So there's only one person that attends all three clubs, and it's going to be Ken, because he's the only one that's in all three clubs. So in this case, we can just write down Ken for that. So how many children are in Miss Davis's class? So in this case, we're talking about a cardinality problem. So again, this would be like the N of, so technically like A union B union C, because in this case, all these kids are in Miss Davis's class, so we want to know how many there are. So we can either count in the circle or count on the list that I wrote down, but either way, we're going to get 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14, 15. So it looks like there's 15 kids total in Miss Davis's class. So then it says how many children attend only the book club. So in this case, so the only ones that attend the book club would be just the ones that are, so not like Jan and Luz attend the book club, but they attend other clubs. So when it's saying how many attend only the book club, we're looking for just the ones that are in the book club alone. So in this case, what we're looking at are just Pete and Nancy in that case. So they're the only two that are just in the book club, and that's the only club they actually do. All the other people are in the book club, but they also do other clubs. So in this case, we only want to know the number, so we're just looking at two, Pete and Nancy in this case. All right, so now let's look at how many children attend the art club or the computer club. So again, art club or the computer club means they could be in art, they could be in the computer club, or they could be in both in this case. So when we're trying to figure out who they are, what we're looking at is, oh, let me use the yellow. So we're actually looking at all these folks. So in this case, A union C would actually give us everybody that's in the art club and the computer club. So again, if we just kind of go through and count, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So there's 13 that attend the art club or the computer club. And then finally, how many children attend more than one club? So let's see if I erase this, whether erase, good. Yay, that's what I wanted. Erase just what I wanted. So in this case, what we're looking for are how many kids attend more than one club. So we're looking for people that attend 2 clubs or 3 clubs. So what that means is we're actually looking for the intersections of these guys. So that means we're looking for these people that are in the middle. Because remember, like Anna, Cindy, Jane, Tad, they just are in the art club. Pete and Nancy are just in the book club. Joe, Robin, and Don are just in the computer club. So to find the people that are attending 2 or 3 clubs, we need to look to those middles. So in this case, we've got 1, 2, 3, 4, 5, 6. So there's 6 that are in 2 or more clubs in this case. So, and in this case, the way we wrote them, if it wasn't asking for numbers every time, we could actually list the names and stuff like that. But in this case, it just cared about the cardinality. So, all right. Is that okay for example 2 there? So again, a lot of stuff going on. Again, we've got lots of time to practice these guys. So feel free, struggle with it, ask me questions. We'll get there. All right. Let's skip on to example 3 real quick here. At any point in time, if you want to pause the video and walk away and take a break, this video could be longer than I was hoping for. So feel free, pause it, walk away, get a drink, play a video game, relax or something if it's a little overwhelming, and come back to it. But all right, so example 3, Brianne surveyed students in her school to determine what types of movies they prefer: fantasy, comedy, both types of movies, or neither. The results are given in the Venn diagram below. So in this case, set A is the fantasy movies. Set B are comedies. And then in this case, we've actually gotten lucky because all the stuff's already, things have been labeled for us. So we've got 13 people that are in the fantasy, just fantasy. 6 who like fantasy and comedy because they're in the middle. 24 who like just comedy. And then we've got 6 that didn't like either kind. And so that's kind of what we want to do first, is kind of go through and identify these different pieces. So first, said how many students did Brianne survey? So what we want to do is add up all these numbers together. So 24 plus 6 gives us 30, plus 13 gives us 43, plus 6 gives us 49. So it looks like she talked to 49 different people. So in this case, so first off, so why do I have science fiction down here? That's not good. This should be fantasy. Look at that, I've screwed this up totally. So let's fix this. So how many students like fantasy? Oh, I've got it screwed up all over the place. Here, hold on, let me fix this first. I'll fix it on your guys' sheet so you won't have to worry about it, but for the video, just ignore it for now. Oh my goodness. Apparently I don't know the difference between science fiction and fantasy, it looks like. So, alright, so now that I've got all those fixed, so how many students like fantasy in this case? So that's going to be anybody that's in all of A in this case. So even the part that's, the ones that like comedy also, They still liked fantasy. They just happen to like both. So it's going to be all the people that are in A. So in this case, we're going to take 13 plus 6, and that's going to give us 19 students liked fantasy. Now, when it says how many students only like fantasy, so that's where we want to get just that 13. So we don't want to include the people that like both categories. So in this case, they only like fantasy. That's all they like to watch. That's it. So they're going to be just 13 in that case. All right, so let me erase that. So now, how many students like comedy? So again, just like before, the number of students that like comedy are going to be all the students in B. So in this case, so even the 6 that like comedy and fantasy, they get counted because they like comedy. So we're going to take 24 plus 6. So it looks like 30 likes comedy, or comedy. And then finally, how many students like comedy but not fantasy? So again, that's going to be the same way C was worded. How many students like only fantasy? So those mean the exact same thing. Like they're just worded slightly different, but they mean the same thing. So in this case, that means we want to eliminate these ones that also like fantasy. So we're looking at just these guys over here. So it's just going to be the 24 in that case. So let's go down here. Oops, I put it in the wrong spot. Sorry. So geez. All right. So how many like both fantasy and comedy? So in that case, what we're looking for is people that are in both circles in this case. So if we go down here, say in blue, so we're looking for anybody that's in either circle in this case. So including the people in the middle, because again, they like fantasy, they like comedy both. So we want to add all of those guys up. So we're looking at 13 plus 6 plus 24. So we're going to get 43, it looks like. So 43 students like both fantasy and comedy. So in this case, how many like fantasy? Oops. Oh, actually, hold on. Go back. I messed that up. Sorry, I misread it. Blah. Let me erase this. So whenever we're talking about ands, this is a good thing to remember. So intersection, another way to write this down, is A and B. So it means that they like both of them at the same time. When you see a union, that's the same thing as A or B. And so I totally misread the question and messed everybody up. So ignore what I just said there and go back. So in this case, since we wanted fantasy and comedy, that means they have to like both fantasy and comedy. So even though I just kind of misworded it. So what we're looking for is we're looking for just these folks in the middle. We're looking for the intersection in this case. So it's just going to be those 6 that like fantasy and comedy, both. All right, so G is what I should have answered for F the last time. So fantasy or comedy. So in that case, because you could like just fantasy, you could like just comedy, or you could like both. And that's what it means to be in the or situation. So if I take like this orange, let me erase that. So that's going to tell us anything that's in the circle is going to be our or in that case. So again, just like I had for the last answer that I messed up, we'd get 13 plus 6 plus 24. So again, 43, just like last time. All right, so now, how many like neither? So how many people don't like either of the types of movies? So those are going to be the ones that are in the outside. So in this case, if I erase this, those are just going to be these folks that aren't in either of the circles. They're going to be the ones that are in the rectangle but not in a circle. So in this case, there were 6 students that didn't like fantasy or comedy. So they're going to be the ones that like neither. So down here, how many like neither will be 6. And then how many do not like fantasy? So again, this is kind of a complement one. So we want to eliminate anybody that's in the fantasy section. So we don't want to be in the fantasy. So if we were to shade a complement, so I'm shading parts even though I don't have stuff written there, but that's fine. So what we're looking for the people that are just in B or don't like either one of the movies to begin with. So in this case, what we're looking at is the 24 and the 6 on the outside are the only two that fit into that don't like fantasy. So because the 6 inside and the 13 inside both like fantasy. So it looks like we've got 24 plus 6, which gives us 30. And then finally, oops, forgot to read it. How many do not like comedy? So again, same thing. Let's clear this up. So we want to do the same thing, but now the opposite. So we want to do shade in everything but comedy. So let's do pink. So in this case, we can include this stuff in fantasy. We're going to include those 6 on the outside. And so we just don't want to include anything that's in the comedy section. So we don't want to include this 6, and we don't want to include this 24. So the only thing that we get is this 13 that liked fantasy, and the 6 that didn't like either one at all. So in this case, whoops. Now there's a picture of my foot, so that's not good. So we're looking at 13 plus 6 gives us 19 in that case. So again, even though they're using words, we want to think about them in terms of intersections, complements, unions, all that kind of stuff. So you don't have to write them down, but that's what you're thinking of when you're trying to actually draw out these diagrams, figure out who lives where and stuff like that. So if you have any questions about that, definitely let me know. If you get stuck or anything, definitely shoot me a message so we can talk about it. Otherwise, the rest of these guys are for you to work on. So we should be able to actually work on these on our own. So there's actually like 8 practice problems. So what I thought I would do is kind of similar to what we did for the problem solving ones in chapter 1. I'm going to assign everybody their own problem, have you guys work on them on your own, like make sure you know how to do it, then take a video kind of explaining what you do, explaining how you're filling out the chart and stuff like that. Again, if you want me to look at it before you actually make the video, definitely, I mean, that would be totally fine with me. And then we'll upload them and share them at the next class so we can see how everybody did. So that way you'll have over the weekend to work on them. So definitely let me know if you have any questions or anything like that. Good job. This is kind of the last of the hard stuff with set theory, so we're going to get more into the how we're going to apply set theory in the next sections. So these two are probably some of the trickier sections we're going to work on. So I think you guys have done a good job. So hang in there, and I will see you tomorrow. So ask me if you have any questions. Good luck.